Hello everybody, getting ready to do lesson 9.5 part 1 pre-calculus math today. And 9.5 part 1 deals with polar coordinates. You got 12 points that will go into your notebook or your notebook guide, and 40 points here will go into your classwork sheet. Have those out, students, name, date, period, onliners, homeschoolers. Here's your due date. And we'll start out with our today's bell work, teachers and students, and use the law of sines or the law of cosines to solve these triangles here. A bit of review. So drag your notes out, students. Give your students 5-6 minutes for this. Teachers, pause your video for 6 minutes. Welcome back for today's solutions. 101, A equals 13, B equals 19. And then C equals 25 for 101 here. We're going to use law of sines or law of cosines. So our cosine A here, it would be B squared plus C squared minus A squared over 2BC. We plug in here, we get 0.86 for cosine A. Then we use our calculator, we get cosine of the inverse cosine of 0.86. Will be 30.7 degrees. Now that we have that, we can go cosine B now. A squared plus C squared minus B squared over 2AC. And we get this number here for cosine B. And then when we get our angle measure from that, we'll get 48.2 degrees for B. So now we have 180 minus 30.7 minus 48.2. We get 101.1 degrees for C. So we have our A, B, and C for that. And then down here for 102, A equals 24. So we're giving one angle measure here. Then we're given two side lengths. So we can use our law of sines here. Sine B equals B sine A over A. That cranks out to 0.2440. So our B in this situation will be 14.1 degrees. We have two angle measures now. And then so we can get C equals 141.9 degrees. And to figure our side lengths now, C will equal A sine C over sine A will be 15.17 for the length of side C. So that goes way back. Okay, into our page 1 of our classwork for today. The introduction. So far you've been representing graphs of equations as a collection of points x, y in the rectangular coordinate system, where x and y represent the directed distances from the coordinate axis to the point x, y. In this section you will study a second coordinate system called the polar coordinate system. To form the polar coordinate system in the plane, fix a point O called the pole or the origin, and construct from O an initial ray called the polar axis as shown. So this is our O here. R equals directed distance here. Theta would be our directed angle, and then here would be a polar axis here. So, and construct from O an initial ray called the polar axis. So this would be our polar axis here. And then R is our directed distance here. So then each point P in the plane can be assigned polar coordinates r theta as follows. So 1, R is directed distance from O to P. This is our directed distance here from O to P. And then theta is the directed angle counterclockwise from the polar axis to segment OP. So this would be our counterclockwise movement here of what they call directed angle here from our polar axis to our from this point here from our pole. So plotting points in the polar coordinate system, A, the point r theta equals 2 pi over 3 lies 2 units from the pole. So 2 units from our pole, which is here. on the terminal side, and this angle here, or pi over 3, would be this angle here from this axis to where our coordinate is here. Of the angle theta is pi over 3. So the terminal side is pi over 3 here. This would be pi over 3, which is a 60-degree angle here. B, the point r theta equals 3 and negative pi over 6 lies 3 units from the pole on the terminal side of the angle shown. So now we're going to go in the negative direction here, pi over 6, which would be a negative 30-degree angle here. That's where that coordinate would be there. Okay, so we're getting that down. C, that would be 3, 11 pi over 6. So we're going all the way around like this to 11 pi over 6, and then coordinate would be 3 here. Coincides with the point of 3, negative pi over 6. So this would be the same thing as negative pi over 6 would be here as well. So let's try one. In these exercises, plot the point given in polar coordinates and find the 3 additional polar representations of the point using negative 2 pi is less than theta less than 2 pi. So we have this situation here, 3 and then 5 pi over 6 is what we have there. So when we plot that, we have 3 here, so we'll have 3 circles here. It'll be 3 units out here. And then 5 pi over 6 will be almost a 180 here. But 5 pi over 6 will be a 150-degree angle here. Which would that be? And see, plot the given point and then find 3 additional polar representations of the point using. So students, I'm going to let you find 3 additionals to represent that. Use your imagination. This goes back to, like, I don't know, 8th grade algebra or geometry, 9th grade geometry, 10th grade geometry. Okay, in rectangular coordinates, each point xy has a unique representation. This is not true for polar coordinates. For instance, the coordinates r theta and r theta plus 2 pi represent the same point as illustrated in example 1. Another way to obtain multiple representations of a point is to use negative values for r. Because r is a directed distance, the coordinates r theta and negative r and theta plus r represent the same point. In general, the point r theta can be represented as r theta equals r and then theta plus or minus 2n pi, or r theta equals negative r and then theta plus or minus 2n plus 1 times pi, where n can be any integer. So moreover, the pole is represented by 0 theta, where theta is any angle. So we have a lot of different ways of expressing the position on the polar coordinate system. Multiple representations of points. Plot the point here, 3, and then negative 3 pi over 4. So, and then find 3 additional polar representations of this point using negative 2 pi less than theta less than 2 pi. So the point is shown here. Here is our 3 and then negative 3 pi over 4, which would be here. So we're going in this direction here. This would be negative 3 pi over 4. And then 3 would be like 3 orbits out, I guess is one way that you could describe it. It would be 3 orbits out. 3 other representations would be as follows. So we have 3 and then negative 3 pi over 4 plus 2 pi. It would be 3 and then 5 pi over 4, meaning adding 2 pi to theta in this situation here. And that would be 5 pi over 4. And then negative 3, and then negative 3 pi over 4 minus pi. Replace r by negative replace r by negative r, so it'd be negative 3. Okay, so I guess you could describe it as negative 3 as well. And then subtract pi from theta. In this case here, then you would end up with negative 7 pi over 4 in this situation here. You subtract pi from theta, which would be an addition actually of negative 7 pi over 4, because you would be down here in your third quadrant down here. So that would be, in this situation here, this would be the same as that. And then negative 3, and then negative 3 pi over 4 plus pi equals negative 3, and then pi over 4. Replace r by negative r, and then add pi to theta. And then that will give you the same position there as well. So plot the point given in polar coordinates, and then find 3 additionals. This is yours here, students. Find your 3 additionals of using this parameter here, negative 2 pi less than theta less than 2 pi. So we have negative 1 and then negative pi over 3. So for that particular plot here, this would be negative 1. So this would be negative 1 and then negative pi over 3. So negative pi over 3, let's see, pi over 3 be a negative 60 degree angle. Using this as your reference angle here, be negative pi over 3 and then negative 1 would be that position there. And then come up with 3 others, students. Okay, moving on here. Coordinate conversion. So to establish the relationship between polar and rectangular coordinates, let the polar axes coincide with the positive x-axis in the pole with the origin as shown in this figure here. So this is your pole, this would be your r, and then your original x-axis here would be your polar axes as well. And then here's your theta for that. So because xy lies on a circle, this is your xy out here, of radius r, it follows that r squared would equal x squared plus y squared. Moreover, for r greater than 0, the definitions of trigonometric functions imply tan theta equals y over x, cosine theta equals x over r, and then sine theta equals y over r. You can show that the same relationships hold for r less than 0. And how do we do that? The polar coordinates of r theta are related to the rectangular coordinates xy as follows. So polar to rectangular would be x equals r cosine theta, then y would equal r sine theta. And then rectangular to polar would be tan theta would equal y over x, and then r squared, we know, equals x squared plus y squared. Let's try one. Polar to rectangular conversion. Convert the point 2 pi to rectangular coordinates. So for the point r theta equals 2 pi, you have the following: x minus r cosine theta equals 2 cosine pi equals negative 2. And then y equals r sine theta equals 2 sine pi equals 0 in this situation here. So the rectangular coordinates are xy equals negative 2 and then 0. So negative 2 and then 0 would be right here. R theta equals 2 and then pi. Then xy, this xy position would be negative 2 and then 0 for this point. So negative 2 and pi, remember pi is your 180 degree position, and then your 2 would be 2 units out from your pole, from your origin here. So that'd be another way that you could look at it. Okay, so in this 17 here, plot the point given in polar coordinates 4 and then negative pi over 3, and find the corresponding rectangular coordinates for the point. And then this one's on you, students. So for 17 here, see x equals 4 cosine negative pi over 3 equals 2 when you multiply that out. And then y equals 4 sine negative pi over 3 equals the negative of 2 times radical 3, and then the rectangular coordinates will be 2. Here's your rectangular coordinates, 2, and then negative 2 multiplied by radical 3, and then that will be your position there for that point. And that is 9.5 Part 1 Pre-Calculus Math classwork. Here's my email, animatedpowerpointmathvideo@aol.com, for questions or course materials. Thank you.